Namaste. So welcome to the class. So today we are going to discuss about the signal flow graph representation. In the previous class we have seen what is the meaning of signal flow graph representation. It is a graphical representation of a given system. So that is what we are going to call as what? Signal flow graph representation. And also we discussed how to write the signal flow graph from the set of equations that we have already learned in the previous class. And also we discussed about the how to write the signal flow graph from the given block diagram. Okay, so now we are going to discuss some of the terminologies. So I think in the previous class we stopped in the middle, right? So we are going to continue the same thing. There is a terminologies of signal flow graph representation that is very much important to solve the problems. Okay, so here I have taken what is the terminology used in signal flow graph representation. So here I have taken one example. With this example, now I am going to explain you what are the various terminologies of signal flow graph representation. In that, the first one is called as source node. What is the meaning of source node? The node which is having only outgoing branches. So that we are going to call as what? Source node. Here there are different nodes are there: x0, x1, x2, x3, x4 and x5. Out of these 5 to 6 nodes, which node is having only outgoing branches? It is x0. So x0 is a node which is having only outgoing branches. Hence that we are going to call as what? Source node. I am explaining with the help of this example. So here source node is x0. What is the meaning of sink node? The node which is having only incoming branches. The node which is having only incoming branches. So that we are going to call as what? Sink node. So here is the sink node. Here please pay attention, x5. So this node is having only incoming branches. Therefore, the sink node is a x5. Next, what is the meaning of chain node? Chain node, the node which is having both incoming as well as outgoing branches. So that we are going to call as what? Chain node. So in this case, so how many chain nodes are there? So here we have x1, x2, x3 and x5. Sorry, x1, x2, x3 and x4. So these 4 nodes is considered as chain node. Why it is called as chain node? Because these nodes is having both incoming as well as outgoing branches. Hence it is called as what? Chain node. So I can write the example as what? x1, x2, x3 and x4. So these 4 nodes are called as what? Chain node. Now what is the meaning of forward path? Okay, so here the path that we can travel from the source node to the sink node. What are the various paths are there to transmit the signal from the source node to the sink node? So that we are going to call as what? Forward path. So here how many forward paths are there? For example, x0, x1, x2, x3, x4 and x5. So this is one path, right? So I am going to write the forward path number 1. So the P1 represents x0, x1, x2, x3, x4. So and x5. So this is a forward path number 1. So there are many other nodes are there, which is the x0, x1, x0, x1. From x1, I can go to x3 with the help of this signal, right? x1 to x3, then x4, x5. This is the path number 2. So what is that? x0, x1, x3, x4 and x5. I have another path is there. x0, x1, right? x2, x3 and I can go to the xy, right? So this is another forward path. like that, I have another path x0, x1, x3, next x5. So there are totally 4 forward paths are there. Have you understood? What are the various paths from the sink node to the from the source node to the sink node? So the various paths, so that we are going to call as what? Forward path. Okay. Okay, so the next one is called as feedback loop. What is the meaning of feedback loop? The loop which starts and end at the same node. Okay, which starts and end at the same node. At least it need to travel the other node, and without repeating any other nodes twice. What is the meaning of this? So there are various feedback loops are there in this problem. So which are those? For example, do you have any feedback loops in the x1? Yes, we have a feedback loop. What is that? Okay, we don't have any feedback. So from x2, we have a feedback loop. So I can go to x2 to x3, then x3 to x4. Then by traveling this 2, I can come back to x2. Okay, so this is the one of the feedback loop available over here. So what is the meaning of this? The loop which starts and ends at the same point. Okay, which starts and terminates at the same point, and at least it should travel the other node. It should travel the other node without tracing the nodes twice. Without tracing the nodes twice. So that we are going to call as what? Feedback loop. For example, x2, x3, x4, then back to x2. So that is one of the feedback loop available over here. Okay, for example, I am writing over here available feedback loop in this example, that is x2, x3, x4, then back to x2. I am just writing the path. Okay, this is about the feedback loop. What is the meaning of self loop? The self loop is one which starts and eliminates at the same node. Okay, which starts and eliminates at the same node without traveling any other node. Without traveling any other node. So that we are going to call as what? Self loop. In this case, there is a loop, self loop, which is going to start from x3 and it is ending at the x3 without traveling the other node twice. So that is what the self loop. So what is the example here? x3, right? So here this starts and ends at the same point without traveling a other node. So this is called as what? Self loop. What is the meaning of path gain? So in the previous one we discussed that how many forward paths are there? There are 4 forward paths are there. What is the path gain means? So here x0 to x1. So this is one branch. So above this branch what is there? Nothing is written, means it is called as 1. The path, the transfer function of this path is, or path gain of this branch is 1. So for example, I am going to take the path gain of from x1 to x2, it is 2, x2 to x3 it is 3, x3 to x4 it is called as 4, x4 to x5 it is called as 5. For example, I have taken these are the path gain of the branch 2, x1 to x2, x3, the path gain is 2, x2 to x3 the path gain is 3, x3 to x4 the path gain is 4. In the same way, x4 to x5 the path gain is 5. So what is the forward path gain or a path gain from x0 to x5? For that, so if the forward path is x0, x1, x2, x3, x4 and x5, that is the one of the forward path. So the path gain of the forward path number 1 will be equal to 1 into 2 into 3 into 4 into 5. Okay, so this we are going to call as what? Forward path gain number 1. In the same way, we can find out the path gain of all the remaining forward paths. So that we are going to call as what? Path gain. Okay. So these are the terminologies which is very much required for us to solve the problems. Okay. So now let us discuss some more definitions, some more terminologies. Okay. Now few more terminologies. The next one is the dummy node. What is the meaning of dummy node? In some cases, so there will be a no source node or no sink node. For example, you consider this example. So in this one, so which node is called as source node and which node is called as sink node? What is the meaning of source node? The node which is having only outgoing branches. So that we are going to call as what? Source node. The node which is having only incoming branches. So that we are going to call as what? Incoming branches. In this case, none of the node is called as source node or none of the node is called as sink node. For example, if you say x1 is a source node, as per the definition, the node which is having only outgoing branches, then what it is called as source node. Here we having one outgoing branches, two outgoing branches and one incoming branches. In such cases, what it is called as what? It is called as chain node. The node which is having both outgoing and incoming branches is called as what? Chain node. Hence, x1 is not a source node, it is called as what? Chain node. In the same way, x4 is not considered as sink node. What is the meaning of, what is the definition of sink node? The node which is having only incoming branches, so then only it is called as what? Sink node. But here x4 is having both incoming as well as outgoing branches. It is having two incoming branches and one outgoing branches. Hence, that is also not called as what? Source sink node. It is called as what? Source sink node. Okay. So hence, so in such cases, we are going to add some dummy nodes. Sorry, we are going to add some dummy nodes. I am going to call it as x naught, or I am going to use some as x, xi or something else. I am going to give some naming for those nodes. I am going to connect this to the initial nodes and also outgoing nodes. So here, so the branch of this will be, the path gain of this will be, the gain of the branch will be considered as 1. So now what happens? I am added two separate nodes. The path gain of those branches will be considered as 1. Okay. So then x naught is called as what? Source node. And xi is called as what? Sink node. So we are going to add dummy nodes only when we don't have any source node or sink node. To take that one as source node and sink node, we are going to add some dummy nodes. So these are called as what? Dummy nodes. The branch gain of those nodes will be equal to 1. So there will be no changes in the transfer function of a given system. Now, so that is about the dummy node. Now, non-touching loop. What is the meaning of non-touching loops? So first for that, we need to identify how many loops are there in the system. So for example, 1, so this is example 1 and this is example number 2 I have taken. So here how many loops are there? So which is the loop number 1? So x1, x2, x3, x4 and back to x1, right? So I am going to rewrite it. So this is called as what? Loop number 1. So from the x1 I can go to x4 and back to x1. So this one is called as what? Loop number 2. Okay, and what is the loop number 3? From x2 I can go to x3 and back to x2. Okay, so this is called as loop number 3. How many loops are there in this example? There are 3 loops are there. Loop 1, loop 2 and loop 3. So what we are discussing? Non-touching loops. Out of these 3 loops, we need to identify which loops are non-touching. What is the meaning of non-touching loop? For example, I am going to consider loop 1 and loop 2. What are the nodes of loop 1? x1, x2, x3, x4 and back to x1. What are the nodes of loop 2? x1, x4 and back to x1. See, these 2 loops are sharing nodes. Which nodes they are sharing? x1 and x4. Hence, loop 1 and loop 2 is considered as touching loops. It is considered as touching loop. What we are discussing? Non-touching loops. The loops which is not having any common nodes in between them. So that loops we are going to call as what? Non-touching loops. But loop 1 and loop 2 is called as what? Touching loops. Why? Because it is sharing the common nodes, that is the x1 and x4. Now let us consider loop 1 and loop 3. Okay, loop 1 and loop 3. Loop 1 is this one, x1, x2, x3, x4 and back to x1. What is the loop number 3? x2, x3 and back to x2. Once again, loop 1 and loop 3 is considered as touching loops. Why? It is sharing the common node, that is x2 and x3. Now let us take another combination. What is another combination? We can take L2 and L3 as another combination. What is the nodes of a loop 2? x1, x2, x4 back to x1. That is the loop number 2. What is the loop number 3? x2, x3 and back to x2. So these 2 loops is not having any common nodes in between them. Hence, these 2 loops are called as 2 non-touching loops. So these 2 loops are called as what? 2 non-touching loops. Have you got this one? So this is an example of 2 non-touching loops. Now let us take another example number 2. Here we have 3 loops. For example, x1, x2 and back to x1, x3, x4 and back to x3, x5, x3 and back to x5. There are 3 loops are there. So here, there are combination of 2 non-touching loops. L1, L2 is a non-touching loop. L1, L3 is also 2 non-touching loops. Next, L2 and L3 is also non-touching loop. 2 non-touching loops. So there are how many 2 non-touching loops in this example? Example in this L1 and L2, one combination. This is a 2 non-touching loop. Next, L1 and L3 is also not touching. L1 and L3, comma. Next, L2 and L3. L2 and L3. Therefore, what is the meaning of this? There are 3 combinations of 2 non-touching loops. Have you got it? 3 combinations of 2 non-touching loops. This concept is very much important to solve the problems. So, 3 combinations of 2 non-touching loops. Also, there is a combination of L1, L2 and L3. These 3 loops is not sharing any nodes. Therefore, L1, L2 and L3 is called as 3 non-touching loops. How many combination of 3 non-touching loops are there? 1 combination of 3 non-touching loops. Have you got this one? So this is a combination of what? 2 non-touching loops. So this is a combination of what? 3 non-touching loops. I got it? So here there are 3 pairs of 2 non-touching loops. Here only 3 non-touching loops are there. So this concept is very much important to solve the problems. Okay. So this is the concept of what? Non-touching loop. Okay. Now what is the meaning of loop gain? It is similar to the path gain. So what is the path gain means? It is a product of all the branches in that path. In the same way, for example, so let us take a consider. So let us, this is a 3 and this is a 6. That is a x5 to x6 it is a 3 and then x6 to x5 it is called as 6. What is the loop gain? So loop gain of this L3 will be equal to 5 into 6. It is a product of the branches in that loop. It is similar to the path gain. So these are the 10 terminologies that is very much required for us to solve the problem. Okay. So now today in this class we are going to discuss about the mass and gain formula. Okay. Let us discuss about the mass and gain formula. Okay. Now let us see what is the meaning of mass and gain formula. So let us remember in the block diagram reduction technique how much difficulty we have faced. We need to remember all the 10 rules that is required for us to find out the overall transfer function of a given system, and as well as we need to know the procedure when we need to apply those rules, and after doing all those tedious process then only we are going to get the transfer function. But in the signal flow graph representation, after getting the signal flow graph representation, with the help of a single formula, just applying this small formula, we are going to get the transfer function of the given system. So that is the Mason's gain formula. The person who have determined how to find out the transfer function with the help of a simple formula. So that too with the help of signal flow graph representation. So that we are going to call as what? Mason's gain formula. So we need to know this one, what are the terminologies in this Mason's gain formula, and then we can easily solve the solve the problem. We can get the transfer function of a given system. So here it is the formula. What is the transfer function is equal to summation of Tk delta k by delta. I will repeat once again. It is a transfer function is equal to summation of Tk delta k divided by delta. So this is summation. This is the summation divided by delta. What is the meaning of k? Means the number of forward paths in the signal flow graph. Number of forward paths in the given signal flow graph. So that is the k. Next, what is the meaning of Tk? Means gain of kth forward path. So there will be different forward paths. In the previous example, we have seen there are 4 forward paths are there. So what are the gain of the each forward path? So that we are going to call as what? Tk, gain of the kth forward path. So what is the gain of the forward path number 1, forward path number 2, forward path number 3, like that. Now what is the meaning of delta here? So this is a delta. So delta is nothing but it is a system determinant. It is called as what? System determinant. There is a formula for that. So 1 minus summation of all loops including self loop. 1 minus summation of what? Summation of gain of all loops including the self loop plus summation of gain into gain of product of 2 non-touching loops. We already discussed what is the meaning of non-touching loops. So that is the gain into gain of product of 2 non-touching loops minus summation of gain into gain of product of 3 non-touching loops, combination of 3 non-touching loops. Next here it is minus, next it will be plus. What is the plus? Summation of gain into of 4 non-touching loops. Like that the formulas will continue. This formula is going to continue. So it is when we solve the problem, then you are going to appreciate so how simple it is to solve the simple problems. Now what is the meaning of delta k? Delta k is what? Value of delta by eliminating all loops associated with that forward path number. So this I can explain better when we are going to solve the problems. Okay. So before going to solve the problems in the next class, please remember this formula. What are the various terminologies that you should know? So in the next class you should know the various terminologies we discussed, and also we should know the Mason's gain formula at least in a brief, then we can easily solve the problem in the next class. Thank you. Namaste.